Can we begin?
Okay.
Okay. Only two members are from your team, Team Cosmo Monks. Hello.
Hello.
Yeah, how many team members are there? Only two.
All three.
Okay.
Okay, one is joining. Just a minute. Yeah, there's he is.
Yeah. Okay. Fine. You can start.
So I prepared an intro for that. So can I say that?
Yes, please.
Okay, sir. Okay.
Go ahead.
Okay. Good afternoon, respected Soumya Bagchi sir, our club coordinators, and Molsar Pratham sir. We, the second years at Arka, welcome you all to the finals of Polaris. Polaris is a one-of-a-kind presentation event conducted by Arka to promote the spirit of astronomy and space science among students. This year was the first iteration of Polaris, and it witnessed many impressive presentations. In Phase 1, 35 teams submitted their presentations, each of which excelled the other. From the 35 teams, we shortlisted 10 entries, which will be presently judged by Professor Soumya Bagchi sir. So, without further ado, let's start the Phase 2 of Polaris. On the first round, we have the team Cosmo Monks with Linoptal Rao and Nishan Sharma.
Shall we start?
Yeah. Your
Yes,
time
you can
start.
start.
Yeah.
Let me present. Let me know if you can see the presentation.
We can see it. It's visible.
There is no end to the world. There is only a dissolution and then a re-emergence according to the day of Brahma. Hello everyone, I hereby represent Cosmo Monks. Today we are going to talk about how we will recolonize human civilization entirely in another solar system by using space as a resource. Our paramount responsibility is to save human civilization from extinction. For survival, we have some essential requirements: air, water, food, shelter, and fire. As per the assumption that plants are alike, we don't have to worry about oxygen and water, even though we have an option of mining it from moons like Europa, which has infinite reservoirs for us. And for food and shelter, we could colonize ourselves on a generation ship for few essential years for a development. After reaching there, our first priority will be survival of human race and sending AI probes to find energy and mineral resources, which we can harness easily. Till then, we'll 3D print ourselves home pods, equipment, small ships for descending on the planet that we'll have to, and we'll leave our ship in space till we are done colonizing our new home. We'll extract energy and minerals from asteroids and from planet's core. As we'll sustain on our ship, we'll need the energy to survive and keep our artificial ecosystem stable. The energy we'll use is a byproduct of deuterium fusion propulsion system. It will be initiated by high power laser. Astronomical amounts of neutrons are released, which is because of the electrical neutrality won't be providing any thrust, and will be converted into heat by nuclear powered lasers stored in the thermal batteries. The ship will settle on the Lagrange point in space. Because of difficult times, we'll cryogenical hibernate some people voluntary in order to save human from extinction.
Now, we have to work on settling down on the planet. Here, 3D printing will come out in quite a handful in such circumstances. As we told earlier, home pods, which are soundproof and with thermal insulation and biomass-like tissues, it is also cost and time effective and can be base for our civilization. We could use low-gravity planets nearby for material processing and inert atmosphere for performing some specific tests. Mine the available minerals like phosphorus, silicon, and many more for life support, agriculture, photovoltaic cells, and electronics. As dependency on the solar energy will increase, we have to efficiently use our available silicon and germanium. Focus focus more on recycling and reusing the available resources, and have deuterium from the planet's atmosphere to power us. Asteroid, carbonous, silicous, and metallic space mining can give us infinite resources. Numerous asteroids are rich in metals, organic compounds. For example, asteroid like Antiros for magnesium and silicate, aluminum, iron silicate, and asteroid like Ryugu for nickel, iron, cobalt, water, nitrogen, and many more compounded. Ice could be also be mined from the moons like Europa as a dry ice from Mars polar caps. Now, geothermal energy can also be a very good source of energy and could last for decades and possibly centuries. Furthermore, they can also be used for developing greenhouse for crop production, as it has more compact design than any other energy harvesting uh, processes. Extracting energy from the core of planet will be much more efficient. Unlike any other energy resources, the energy supply is consistent and independent of outside condition. Now, genetic engineering can also play an important role for humans to survive. Genetically modified humans require much less energy to survive and can extract energy from non-conventional energy resources. Building cyborgs will unleash our max power and efficiency. There will be no such barriers to human body in terms of physical strength and durability. The source of energy could be inorganic or organic, and we could more modify as per our wish and metabolism, and we can make our metabolism much more efficient.
Neil, your mic is now off.
Yeah. Can everyone listen me?
Yes, I'm audible.
Yeah. Okay. Energy source and transportation play quite a role in recognizing ourselves on other planet. We need energy for basically everything. One source of energy could be black hole. We could feed stellar masses to the black hole and then collect the photons from the accretion disk as it disintegrates. Another method could be Penrose process, in which we could gain some kinetic energy as we do in gravitational slingshots. But in this method, what we do, we enter the ergosphere of the black hole and then we launch a mass into the black hole, and so that we could gain momentum and get out of the ergosphere. This way we could gain up to 20% of the it's 20% energy efficient, and that's a quite large number in terms of efficiency, as even nuclear fusion is not even 1% efficient. For powering our rockets, we could use antimatter rockets. And in terms of efficiency, it's 100% efficient. We could have some antimatter and matter in our spaceships for propulsion. Nowadays, antimatter only can be produced by particle accelerators, and there also it's a byproduct. We could also use Buzzard Ramjet, which could be which is theoretically perpetual. And in this propulsion system, what we do is we collect the hydrogen floating in the space with the flaps, then we compress it, and then the thermal fusion is done for the propulsion. Dyson swarm is also a theoretical concept for harnessing energy from our solar system. As it will be type 2 civilization, it won't be a big deal for so. And Dyson swarm is just a method. As we have only colonized there, we won't have so much technology. So for that, we could build Dyson's ring. and that could also help us making stellar engines. One of them is Matryoshka Brains, which could help us in computing, and then we could also bring also mix thrusters to move our solar system, just such as shadow thruster, which only requires the light of the sun as a fuel. Star lifting could be done for harnessing energy from our star, and as will remove some substantial portion of the stars for our star. It is not just efficient, and with that it will also improve the life of our star as its mass will get released. And there are three methods of lifting material from our star, which are known as thermal driven outflow, half and puff, which is basically an just improved method of thermal driven outflow, and the other could be centrifugal acceleration. As in conclusion, I'll conclude that we'll try to conserve our resources as we'll reach. Then we'll look for nearby energy resources for mining them, and after that what we'll do is we'll print ourselves homes and infrastructure so that we could descend on the planet for colonizing it. Till then we'll live on the in the ship only. After that we could genetically modify ourselves. That would not be a big deal, as will type 2 civilization, and we'll have all the technology required. And after we could also use concepts such as Dyson swarm, buzzard ramjet, antimatter rockets. Finally, I like to say we'll consistently look for another planets. We'll adapt, improvise and survive. Thank you very much.
Judges, if you would like to provide feedback and ask questions, you may go ahead.
Yeah, should I ask a question?
Yes, sir. Please go ahead.
Yeah. Okay. Why don't you share your like the slides, and I have some questions.
Just a sec. So let me.
Yeah. So here was a discussion about the high power nuclear laser. So how do you?
Yes, sir. It was in the propulsion system for our generation ship. Let me show that slide, sir.
But do you understand that what is a laser, and how do you use a nuclear power as a laser?
No, sir. It was for sir. Let me show you the slide. Only it will be easier to explain. Sir, in the ship we use. Sir, just a sec. So can you see the slide?
Yes.
Yes. So as mentioned, we'll use deuterium fusion for propulsion of our generation ship. The ship will have an artificial ecosystem and will survive. And high power lasers are only used for initiating the system, sir, initiating the propulsion system. And after that, sir, what enormous amounts of neutrons will be released, and those neutrons could be converted into laser energy using nuclear power lasers.
So
and
that is my question. What is the nuclear power laser?
Sir, nuclear power lasers, sir, actually, how do we convert neutron energy into thermal energies? So we have a chamber in that we have uranium dioxide, and there is one more compound. I just couldn't remember the name. And sir, in that we just use the laser for initiating the reaction. It's not some nuclear powered laser, sir. We use some nuclear substances. I told you, uranium oxide.
So from the deuterium fusion, you were expecting that there should be some like the neutron emission, or if I
yes sir
yeah
yes sir.
Okay. So and how do you extract the like the deuterium from the atmosphere?
Sir, we don't have to, sir, extract it from our atmosphere only. Sir, as we'll be leave our solar system, we could have deuterium from our star only. I mean, we'll leave our solar system. This is what we are assuming we have on our generation ship. The problem statement told us that the AI will find a new planet, and we went there. So, sir, this is the technology we are assuming that we have on a ship only.
Okay.
We already have this on a ship, and in the other solar system, after using this, we could harness more from the sun. And
Okay.
even there we don't even need to harness it. We could use some star lifting or maybe Dyson swarm.
Okay. And like, for example, you used also the 3D printing technology. So what kind of things you need to develop for the sustaining in the other planet, for example? So
Yeah, sir, as told, we could use home pods, we could 3D print biomasses, we could 3D print spaceships for some small spaceships for descending the whole civilization on the planet, as we won't take a ship on the earth because that's all we do have. So we'll keep it in the space only for easy operations. And we could print a hand lot of equipments and tools for building and just repairing also.
okay. And you talked about also the black holes. So how do you get the energy from black hole?
Yes, sir. So we feed the black hole stellar masses, and sir, as it'll reach the black hole, it'll disintegrate, sir. And disintegrate, we could collect the photons from the accretion disk, sir.
But like the accretion disk is basically the Einstein ring that is appearing to the edge of this black hole, right? Or like
Sir,
which accretion disk you were talking about? This is the talking about like the outside the ring of a black hole, or which accretion disk you were talking about?
Sir, actually, there is a boundary which we known as
Yes.
which we call horizon, and
Yes, event horizon. Yes.
yeah, sir. And as the density of black hole is quite much, the light bends, but even as if it will cross the horizon, it will never come back. That's we know,
Yes.
sir. So, sir, just outside the horizon, we could have this the region known as ergosphere. Sir, there's the accretion disk. As it will disintegrate, it will form we could say practically that it will be a 2D layer, sort of.
Okay.
And in that portion, obviously, if we feed a black hole with the stellar mass, it won't just go and collide. It first of all, it will start disintegrating and start revolving around the black hole with very high speeds, and it'll start converting into energy. And those energy photons we could collect.
So it is possible to collect those energy photons because, like, for example, if some photons are really going into the black hole, that you cannot collect.
Yes, that we can't collect.
Yes. So how do you, I mean, which part of the photons you are then collecting, or how do you have control in collecting the energy? That is my question.
Yes, sir. As we could collect them. Sir, the point is right now. I mean, theoretically, we could say we could collect them anyhow before it crosses the event horizon. Right now, we may use more energy in collecting those collecting those photons on paper instead of the energy we are getting from them.
See one thing. This accretion disk is not a source of energy. So the source of energy is whenever there are some reactions are going on, right? So accretion disk is just a matter. It's over there. No such thing is going on over there. So, and if something is crossing the event horizon, then yes, please.
So accretion disk is just matter only. Obviously, it's the disintegrated matter that is just revolving around the black hole.
Yes. But like that, from that, how do you get the energy?
Yeah, sir, as it's revolving around the black hole, sir, it's disintegrated, and won't there be lots of friction that'll convert the
no, that
sorry,
is
sir,
like friction.
Yeah, sir, and the particles will disintegrate and then they'll turn into photons. That's our concept.
like particle disintegrate, like when particle disintegrate with matter and antimatter, then you have this, for example, electron and positron are disintegrating, then you have these photons and all those things, right? But we know that there are more matter than antimatter, otherwise we will not survive in the universe.
Yes,
So
sir.
with which this particle will disintegrate, and how do you get the energy? That is my question. I mean, still it is not clear to me, but anyway, we can continue. We can.
Okay, sir.
Okay. Okay. I am done. Anyone else want to ask questions?
No, sir. I think the next team is waiting. So, thank you for your presentation.
Thank you very much for having, sir.
Thank you, sir.
You could leave.
Yes, you can leave.
Yes, you can leave the meeting.
Thank you.
Arudin, you may admit the next team. Okay, so like next up, we have team Astro Homies from IIT Ropar. Please switch on your videos before presenting.
You may start anytime.
Your team is requested to start. Okay.
Yes, sir. Yes, sir. Imagination will often carry us to the worlds that never were, but without it, we go nowhere. Good afternoon to one and all present here. This is Team Astro Homies from the Indian Institute of Technology, Ropar. It's the year 2300, and humanity, now a Type 2 civilization, has left an uninhabitable Earth, only to settle on Planet X in some other planetary system. How do we survive? How do we pass on this seemingly infinite, yet possibly tiny legacy? Over to you, Adya.
I thank you, Karthik. How will the colonies be governed? Well, humans without laws on a planet they barely settled on. Sounds uncanny, doesn't it? Therefore, we believe the first major step should be to set up a governing body, unless we want to start up like our caveman ancestors. With limited resources at hand, this body will aim literally at developing a society and fulfilling basic human needs judiciously. This will provide a sustainable approach to the type of society we aspire to be. Is there a need for a government? What will this government do? Well, this quote unquote government will allot living areas and accordingly resources to the inhabitants of the planet. Also, a general currency would be introduced and bought into the market by means of creating jobs like building structures, teachings, etc. This would ensure that a society does not suffer a major setback. This organization will also overlook other issues like asteroid mining for resources, energy production, etc. Over to you, Pranav.
Thank you, Adya. Another big issue for humans would be food. Under unknown climatic conditions, APH or advanced plant habitat would be the best option as they can be created and modified by us easily. APH is a growth chamber for plant research and cultivation. It uses LEDs and porous clay substrate with controlled fertilizer, nutrients, oxygen, and water release to plants to help them grow. This would be the first step for immediate food security. Water is the source for all life we know so far. Water is a crucial element for survival. Every great civilization flourished near sources of water. For humans on planet X, the hydrogen emitted from the central star would be a major source of water production. Methods like these and advanced biochem would be the catalyst for the beginning of terraforming planet X. Humans are explorers by nature, but have adapted to Earth through centuries of survival on Earth. The smallest change in environmental variables can make a place uninhabitable. Thus, terraforming or modifying that planet's ecology should be a matter of utmost priority and should be done extremely carefully. It is the only long-term solution available to us for making a permanent settlement. Over to you, Dhruv.
Thank you, Pranav. One of the most crucial things for any civilization is energy. Energy can be transformed from one of its various forms into the ones which we can benefit from. Humans will still be able to utilize the already existing methods of energy generation, like fission and fusion reactions, and meanwhile also look out for more ambitious projects to fulfill energy requirements for the generations to come by. By definition, a type of civilization, also called a stellar civilization, can use and control energy at the scale of its planetary system. We will look at some of the potential sources of energy in the following slides. Kinetic energy of asteroids. Asteroids possess huge kinetic energy, which may be used for transportation on a planetary scale. They can also be used as intermediate stops for movement across large distances. This might have a valuable role in the construction of the Dyson sphere. Gravitational fields of planets. A capsule-like rotating structure can be placed in orbit of planets, which can be used to launch stuff into orbits. Some large planets in the planetary system can also be used as gravitational slingshots for long-distance transportation. The central star of a planetary system. The main source of energy for any Type 1 civilization is its central star, where the amount of energy it receives is very minimal as compared to the total energy the star emits. A Type 2 civilization can take this a step further by construction of a Dyson sphere. A Dyson sphere is a megastructure which may be built around a central star. It would redirect its energy and thus help us extract it. Construction of a Dyson sphere shall fulfill all our energy needs. Fuels from other celestial bodies. Some planets and their natural satellites may have potential fuels which can be traced and extracted by a Type 2 civilization. An example in our own solar system would be Saturn's natural satellite Titan. It has huge reserves of methane and ethane. Over to you, Adya.
Thank you, Dhruv. Now comes the topic of hunting for raw materials. Asteroids. Humans would require humongous amount of raw materials, and one of the first candidates would obviously be the asteroids, most of which are dense in silicate minerals. Some large asteroids are abundant in metals like iron and coal, which can single-handedly satisfy entire generations worth of metal supply. Next comes neighboring planets and satellites. Neighboring planets and the satellites will be the next obvious choice. With different physical conditions on different planets, they can be utilized as manufacturing hubs for necessary goods, which can be created from the materials already present there. This would also cut down the production time for faster development. Over to you, Karthik.
Yes, thank you, Adya. So finally, to sum up, humanity forms a governing body to avoid any initial chaos with availability of resources and then manages both daily life and long-term plans. They take the help of techniques like APH for fighting food scarcity and hydrogen for the creation of life-sustaining water. They scavenge for energy resources throughout the planetary system and mine for resources on asteroids and planets. At the end, they take on the ambitious process of creating a Dyson sphere and fulfill their energy needs. A child sitting on the porch of his house watches the sun set. Well, at least that's what his grandpa called their star. He had seen holographic videos of Earth at school and felt thrilled by its beauty. After the initial mayhem of a few couple of years or maybe decades, life will be normal. People will remember what they left behind, and hopefully, as the newer generation appears on the planet X, they will associate themselves with their new home, however it may look like, and hold a sense of responsibility for it. Thanks for being with us on this journey. We are the team Astro Homies. Thank you.
Thank you for your question. Like for the slides, I have couple of questions. So, for example, you talked about this, like about the food problem, but apart from the food, you don't feel that you should have other problems as well, like in settling down in other planet. And the second question is that you talked about the energy resources from outside, like from asteroid or other planets. Is there any plan for the self-sustained development of the energy resources?
Okay, sir. So first of all, I would like to answer your second question. The energy resources that we were talking about, bringing them from other planetary system, those are for like the immediate solution. Because first of all, we would need something to get life running on the planet. At the end, for any type of civilization, the final goal would be creating a Dyson swarm around the central planet, because that would be one of the most feasible long-term solution, but they need to get started somehow. So that's why we thought of getting like resources from other planets for that. And as you talk about the first question, like food, so we thought that the most basic, what could be the most basic thing that any species needs to survive. So it's obviously for humans it would be water and food. Other basic human like things which we need for survival, like clothes and shelter and all, it would be on our bucket list, but I think food and water has the topmost priority. And the central organization we talked about, it would be the goal of that organization to allot land and resources equally and judicially amongst the population living on planet X.
So initial plan are the food and the basic amenities, but like to build a civilization, this is not the only thing. You also need to develop kind of technology and all those things. So that one also has to take into account, right?
And also, like as mentioned in the question, it already says that we are type visualization. So since we already have the developed the technology, then why not go for outer space?
Okay. And my last question is that in one of your slide, you talked about the energy extraction from an asteroid. So how you get this energy from the asteroid?
Yes, sir. So what we meant to,
So can I answer it?
go on,
Yes,
Prof.
yes.
Yeah. So by energy extraction, the actual meaning was like if we have a asteroid in orbit, we can just mount a catapult on it. So let's say this is the planet and there's an asteroid rotating around it, and a catapult-like structure which rotates around it can be used so its lower end passes through the near surface. So we can attach stuff and then use it to like throw it into the orbit. So that's how we are using its energy.
Yes, sir. Actually, our idea came from actually we were watching a couple of videos for this research purpose, and what we saw was that instead of first bringing all the material down from asteroid to our planet and then assembling and all of that, we can just mine it up there and use its already existing like orbital path. So like it's going on around an orbit around the star, and then we can use that energy only to throw it to our destination, that some other planet where we can set up a manufacturing hub and all of that.
It's like a large slingshot.
Yeah, like the gravitational slingshots which are used for like modern day satellites and all.
Yeah, but like for example, if imagine a scenario if this asteroid is also colliding with your planet X or something. So do you have also this kind of?
No, so we are not throwing up the entire asteroid. We are just like, for example, on an asteroid, we mined up some X amount of iron from it, and now we want like to transport it from there to our planet. So we are talking about like when the asteroid is on its path towards the planet, and when it is like closest to our planet, we can then like send any satellite or anything from that asteroid. So we don't have to like spend more extra amount of energy for that.
Okay, so I would like to add up to his point. Like the asteroid belt also keeps rotating in the planets, so we can also send stuff to the asteroid belt, which might rotate and sometime be near the planet, and we can detach from the asteroid belt, the satellite, and then also reach there. And talking about like the catapult thing, if we launch stuff from planet like rockets or anything, it uses a lot of fuels. and that's a very inefficient way. You're right that the asteroid has the risk of falling on the planet, but we there will be like if it throws something, it loses its energy and it will come closer to the planet as the time passes. We will have to attach some engines or rocket propellers on the asteroid itself so that it keeps a safe distance from the planet and doesn't like fall on it.
So you are keeping some propellers with the asteroid so that it doesn't
Yes,
fall.
yes, sir.
Yes.
But then one has to also calculate how much the gravitational pull that your planet X can happen so that there is no free fall of this asteroid on your this planet X, right?
Yes, there can be
Uh,
sensors to evaluate the
so
distance.
first of all, I would like to add that we have assumed one point that this planet is in the Goldilocks zone. So it would be, I believe, at a safe distance from any like life-threatening asteroid. Like we talk about Earth, it is at a optimal distance for life to be. So if there is an orbit like asteroid orbiting very close to that planet, I don't think humanity would choose that planet as a viable home.
Plus, even we are a type 2 civilization, so we are kind of capable to deal with that threat because, we are already harnessing the energy of a star, and asteroid shouldn't be a big deal for that kind of civilization, right? So we thought that will actually be a very, very viable way for us to extract free energy from the asteroid, kind of using it and minimizing our energy consumption.
Okay, thanks, Paul. I am done. Anyone else ask the question? Please go ahead.
I think no other questions. I thank you for your presentation. You can leave the meet now. We'll move on to the next team.
Thanks, sir.
Thank you, sir.
Thanks, have a nice day.
Anilim, you can add with the next team. Sir, the next team's name is Astronomies. They are from ISO Kolkata. Please switch on your video before you present your presentation.
Hello, sir. There's actually a problem with my camera due to which I'm not able to start it. So would that be okay?
No issue, no issue.
Okay, yeah. Thank you. Sorry.
You can start.
Good afternoon. We are Team Astronomy, and this is our guide to a sustainable settlement, a primer for Type 2 civilization. So, we have mainly talked about three ideas. Firstly, energy, which is important for building any successful civilization. Then we have transport and communication, which are required for transport of people and resources, and also for proper coordination between them. And lastly, we have resources, which are essential for building any sort of infrastructure and machineries. Now, we'll discuss upon these ideas in more detail, starting with energy, which will be done by Munish.
Thank you, Anushka. Moving on, we have energy. Am I audible? Yes. Energy. The civilization on planet X is a type 2 civilization and is estimated to need and have an energy consumption of 4 into 10 to the power 26 watts. This is comparable to the output of the star. The inhabitants need this energy to get around, communicate, sustain themselves and their activities. Now, how will they get this energy? They can build a Dyson sphere surrounding the star and harvesting all the energy emitted, or they can collect antimatter by directing X-rays at the star and capturing the generated positrons. The issues are many with this method, mainly the energy required for magnetic confinement of the antimatter and the laser operations, plus the high input to output ratio of the energy generated. Lastly, we look at nuclear fusion. Moving on, we look at some solutions for planet X. Since Dyson spheres, classic Dyson spheres are big solid structures with a lot of material required for completely encapsulating a star, we have thought of Dyson swarms, small units similar to solar panels gathering the energy from the sun, and statite bubbles, which are made of super strong materials similar to carbon nanotubes and collect and release energy in the form of lattice vibrations. The structure will also be stable against space debris compared to a classical Dyson sphere. We move to nuclear fusion, a clean and efficient energy source. It requires hydrogen and simple gases as fuel, which will be fused together to produce energy. These can be collected from the gas planets in Planet X system. For efficient and meeting the required energy standards, we have to do a combination of all the suggested measures. Once initial sources are established, with increased generation, as we get more and more energy, we can have more and more ways of harvesting, exponentially increasing the rate with which energy is produced. This energy will then be stored in high energy storage devices with high density, and these can be transported across the solar system for the various needs which are required. I hand this over to Rohan now, who will discuss the transportation methods of Planet X.
Thank you, Manish. Now I'll talk about transportation and communication system. Fast and efficient transportation models and communication system is essential for any sustainable civilization because it helps in transport of resources and travel between two locations. Efficient and effective communication system is also essential because it reduces the disconnect between people living at different places. Now I'll talk about transportation models. We have thought of two transportation models. One is point-to-point model. In this model, there exists a direct route between any two planet or moon. And next we have spoke hub distribution model. Here we have a hub and there exists a direct route between hub and planet or moon. So we have now talked about which is the better model. So spoke hub distribution model is better because it's more efficient and increases the success rate of each mission. And we have as this solar system is similar to ours, we have strategically decided that Ceres to be our hub. It will act as a central waypoint for all spacecraft. Repeaters will be put up here, which will make the communication system even more efficient as we don't have to invest in transmitters of higher power output. Also, this will make the receivers smaller and thus efficient way to utilize our resources. Why we have selected Ceres as the hub? As it lies outside the orbital plane and it's also in between the rocky planets and gas giant, which makes it perfect for being a hub, as we can travel from rocky planet to gas giant without ever crossing the asteroid belt. And this will make our travel even more frequent, and thus we can make more frequent trips to the gas giants. And we have put up repeaters, as we know that signal strength will go down by 1 by r square, so we don't have to invest in bigger receivers, as the repeater will restore the signal strength. Now I hand over to Rutvik to talk about resource acquisition.
Thank you, Rohan. So now we shall discuss about acquiring resources for our civilization. Now, we are a type 2 civilization, due to which we will be frequently traveling between the solar system, and thus we would need a ton of resources. Now, we already have a lack of minerals and other resources on the planet X, and hence we would require to extract some from the space, and that would be our highest priority. And all our current resources should be directed for the same purpose. With a sufficient amount of resources gained after a few missions, we would be able to divert the resources that we just acquired for other fields simultaneously while keeping the resource gaining missions running. This would be the ideal way of managing resources. So now we talk about extracting resources. From where do we extract them? The ideal source about them. Now, gas giants are a good source of hydrogen and they can thus be used for gaining energy, as we previously discussed. Comets contain ice and some solid forms of carbon dioxide, ammonia, methane, etc., which are not really what we are looking for at this instant. They are basically useless to us. Yes, rocky giants do contain a lot of minerals, but considering that they are bigger in size, that implies that they also have a strong gravity. A strong gravity means that these heavier and thus useful elements that we're looking for will be found more deep into the interior of these planets, and hence it is not viable to go for them considering the urgency of requirement of these minerals. Thus, the only plausible source that we can think of is asteroids. They are generally smaller in size, with ranges from 1 meter to like some sort of 1,000 kilometers, and thus they have a less gravity, which implies a less escape velocity, and thus we would require less fuel consumption for takeoffs and landings, which is very beneficial for our current situation. Now, methods of mining. Since we just discussed that asteroids are small and they have a smaller gravity, we cannot really just dig elements or minerals out of them using a pickaxe, as they would basically just fly off and it would be difficult to collect them that way, like we do on Earth. Instead, we would use the melting point of elements as a critical factor. We would melt the rock to the melting point of the element having a lower melting point among the elements composing the rock. Thus, we would be able to extract the liquid form that just melted, and that could be recondensed separately in some frost chambers that would be located inside the spacecraft that are set up near the asteroids. Thus, we would be able to recondense those elements and use them. So now that we have acquired our resources, we now talk about where do we use them. We must be able to use them wisely and only for the correct requirements and in the appropriate situations. Construction of infrastructure would be necessary since we also have to bring normalcy to the humanity after recovering from such a frightening voyage. Accommodation of people into tall buildings would be ideal from space management point of view. Construction of research facilities and laboratories should also be started up. Medical and agricultural related facilities should be restarted. Now, traveling within the colonies would also require top tier transportation systems, which would be done with the help of these resources. Last but not least, the civilization, in order to be able to regain its former glory of having interplanetary colonies and settlements, would require an efficient communication system. With ample resources and energy, all of this could be made possible. Back to you, Anushka.
So to sum it up, for energy, we have the Dyson swarm and nuclear fusion as energy sources, and an advanced storage cell for storing energy. For transport, we have the hub and spoke model, which enables a well-functioning transport system. For communication, we have repeaters, which enable increased efficiency. And lastly, for resources, we have asteroid mining as a suggested solution. These are our proposed ideas for running a sustainable and a successful civilization on planet X. We are Team Astronomy. Thank you.
Okay, thank you for this nice overview. So I have a couple of questions. So first question, you have brought a very interesting topic about this antimatter collection or antimatter like the storage. So
Yes.
can you just give some idea how do you do that, or you say that about the
From
trapping and all those things?
yes. From the conventional literature which we have studied, antimatter, we direct X-rays at the sun's top layer, corona, and from that it generates positrons, which these positrons are then magnetically contained. Uh, I don't know the exact method or machine used to contain these positrons, but from the literature I've read, the input to output ratio is very high. Like we have to invest in lasers for getting the positrons, then we have to invest in the magnetical containment systems. So that is why when if suppose we do annihilate this antimatter and we collect the energy released from it, still also it will not we will not be able to break even. That is my point.
Like I do not understand your last comment. If you want to like collide with the matter with antimatter, you will get the energy. But why, like, what is not unbreakable?
Not unbreakable. We are talking about this can be done. If we This can be done as a proof of concept, but I'm talking about to make it sustainable. Like we are giving some input, but the output is more higher than that or sufficiently higher than that. So according to current literature, it is not possible in a single solar system unit. There are some zones which have been theorized to be completely made of antimatter, and in those areas we have to do less input, so less input of energy. So in that method maybe it will be feasible for us. But for Planet X is almost analogous to our solar system, so we do not have viable sources of antimatter in our solar system.
Okay. And
Sir, can I
also-
add something?
Yes, sure. But like before that, let me also make a comment that we also have to keep in mind that in our universe, like the presence of or the amount of the matter is larger than the antimatter, right? So,
Yes. Absolutely.
yes, please, Rohan, continue.
Yeah, so there are like concept like dark matter also. Like we can theorize like there could be some sections or pockets of antimatter which we can utilize, like directing strong lasers at the sun and then directing those the positron streams via the strong magnetic fields, and then using those along with the the antimatter pockets, we can in like theoretically like get huge amounts of energy which will be practically infinite for us. We can have such models if we find a antimatter pocket or some.
Yes, that is what I was talking about. Like antimatter pockets are theorized to be found, but and there our input will be sufficiently less than the output to make it worth our while.
But this antimatter pocket is kind of the hypothetical idea, right?
A hypothetical idea.
Right.
Yes.
Mm-hmm. Okay. Yeah.
So,
And
do you have any more questions or suggestions
yes.
for us, sir?
No, I have one or two questions. So you talked about this transportation and communication. You talked about this hub kind of thing, and there was a mesh kind of thing, right?
Yes, sir.
So here was a mesh kind of structure, and there was a hub kind of structure. So you are preferring the hub over the mesh. Can I ask why? Because why I'm asking this, because if there is some kind of network interaction, then your mesh kind of network will keep you still some type of communication still flowing on, because not all the lines of the mesh can be down at the same time, right?
Sir, we are proposing a hub and spoke model for the transport, and mesh model is also for the transport. For the communication system, we are using repeaters.
Okay, but then among this hub and this mesh, which one you will prefer then?
For communication system?
Yes.
For communication system, I'll prefer mix of, it will be a mix of both hubs and we have current communication system. There we have individual mobile phones and we have repeaters, and these there are clusters of from each hub there are connected multiple meshes, and these mesh are connected to hub itself. So it's a meta structure kind of. So I'll try to replicate that, because and for the transport we are using the hub and spoke model, because this is the model which is being used by all the current delivery services. As we know that we don't have to travel from, let's say, planet X to Jupiter like counterpart over there. If our spaceship get damaged in between, we can go to the hub and then get itself repaired, and then it can continue its journey forward. But in our point-to-point model, that wouldn't be possible. We would have to invest in better engines and better fuel storage devices. But we are eliminating that and using the hub as our source, where we can get our spaceship repaired and its battery charged, and where it can also it can take less load from the planet X, get itself equipped for the mining, and then it can go on for the further journey for mining.
Okay, and also you were talking about the repeaters, but may I ask, why don't you consider any sort of amplifiers, because there could be the possibility of the attenuation of your signals or these communicating signals?
Yeah, sir. We are using repeaters because we know that the power law, we know that 1 by r signal strength decreases by 1 by r square. So if we are using the amplifier, the amplifier will be there in our device itself, which will increase, let's say, by a factor of 10. But if I move, let's say I have to receive the signal at 10 kilometer distance, then the signal would decrease way faster. like the we are amplifying by some factor, and but reduced is happening by 1 by r square. So it's a square term. So that way it's more efficient or better to have a repeater kind of model rather than increasing the increasing like making amplifier which can increase the signal strength by many folds.
But this repeater will actually, I mean, you are putting the repeater at some distances, right? So let's say you have a signal at, let's say, r equals to 0 or whatever, like r equals to 10 meter, and after, let's say, 100 meter, you put the repeater. But at 100 meter, the signal already got attenuated. So when it repeats, it will repeat the attenuated signal or the original signal.
No, sir. It will repeat. It will receive a signal. We will make a repeater very big, so it can collect max amount of signal. So our signal to noise ratio is really high, and then it got some signal, and then it will amplify it, and then increase it at a really high power output. So we don't have to do this for individual pieces, but we can have a system which does it for us.
Okay, and you talked about the signals to noise ratio, so this will be my last question. So how do you then like understand the signal not coming from the other sources? Like how do you suppress the noise actually? So that is the question.
First of all, what we can do is can have like specific pattern, like we can send signals in some specific pattern, so we don't see the noise very much. So like our signal pattern is such that the noise is not that visible, or we can use is like have really big like yes sir.
Yeah, so you can send a signal in a particular frequency, for example.
Yes sir.
Okay, because usually what the other astronomical sources, like what emits the signal, they have a wide range of frequencies.
Yes sir. Yeah.
Okay, thank you very much. Yeah.
Thank you sir.
Thank you, sir.
Thank you, sir.
Do you have any suggestions for us?
Thank you, sir.
No, like
no suggestions whatsoever.
Yeah.
So should we leave now?
Yeah.
Thank you very much.
Thank you very much.
Thank you, sir.
So next up, we have Team Crux from IIT Jodhpur. Please switch on your videos before presenting.
You can start.
Yeah, hello everyone. Vidhi, can you present? Yes. Did you know that space has the ability to produce a triple bottom line, or RO3, that is written on investment, innovation, and inspiration? This is quoted by Robert C. Jacobson. Good afternoon. My name is Vidhi Gupta, and we are the team Crux from IIT Jodhpur. We are here today to discuss a problem statement given by Polaris. You will find this interesting because you will get to know how we can use this huge space as a resource for our living. I would like to recognize and thank Bhavya Soni, Sneha Gupta, and Jatin Lohar who worked on the project. Today, we will talk to you about what is the problem statement, our proposed solution, the central idea behind the solutions, and how to implement these solutions by overcoming the summons. Now, Sneha will talk about the proposed solution and the problem statement.
Thank you, Vidhi. As our problem statement given by Polaris states that we are in some year 2300, the human civilization has no other option but to leave the Earth and settle on some other planet X. The planet X is located in a solar system very identical to ours. Planet X is scarce in various resources like metals, minerals, and energy fuels, which can last up to 5 years at max. And because of this, we have no other option but to use the resources of other planets and stars of our solar system. As we are type 2 civilization on Kardashev scale, we are able to utilize the resources of neighboring planets and stars of our solar system. In such a condition, how would we use space as a resource to survive? After going through a lot of literature and according to our understanding, we propose two solutions. The first solution is based on using asteroids to extract its minerals after artificially forcing it to collide on a planet. And the other is based on using antimatter to produce energy resources from annihilation. Now, Jatin will talk about background research and the central idea of both the solutions.
Thank you, Sneha. Continuing the discussion, you all must have heard about asteroids. So, asteroids are not just rocks, but a bag of minerals. As found, the asteroids are of two types: C type asteroids and S type asteroids. C type asteroids are basically rocks, while S type asteroids are basically minerals. Now, let's discuss the difference between these two types.
I think his connection is lost. Can you tell your teammate that he has lost this connection and that he should rejoin? Oh, I think he's back.
I'm really sorry, like I got.
No problem. Continue the.
Yeah, yes, I'm sorry. Continuing the discussion, you all must have heard about asteroids. So, the asteroids are not just rocks, but a bag of minerals. As found, the asteroids are of basically two types: C type asteroids and S type asteroids. C type asteroids contains high water content but relatively low mineral content. It has a lot of organic carbon, phosphorus, and fertilizer ingredients. Another type of asteroid is called S-type asteroid. It has low water content but relatively high mineral content such as nickel, gold, platinum, and cobalt. It can be used to extract minerals. Next source can be an antimatter. It is composed of antimatters, antiparticles like positron, antineutrino, and antiproton. When high energy matter and antimatter collide, they produce a pair of gamma rays that can be used to extract energy. This results in formation of antimatter plants. This process is called annihilation. Moving to the central idea of the problem, we are using the theory of relativity, energy and mass. Since energy and mass were once considered separate entities in classical physics, but according to special relativity, energy and mass can be interchanged. Now, depending on the energy of system, mass can either be created and destroyed. A body has a rest mass of m and a rest energy mc square that can be converted into useful energy that is of various kinds. This also implies that energy is released from a body when such a conversion is taken place. The rest mass will decrease if such reaction takes place. Now, Bhavya will explain the two solutions and the way to overcome the hurdles.
Thank you, Jatin. So, as discussed, we focused on both mineral and energy resources. Let's have a look at the solutions in detail. So, our solution one is colliding asteroids. Since asteroids are rich minerals floating in space, why not use them as our mineral source? So, our solution is to create asteroid shower or to smash them into the planet. When it enters the atmosphere of the planet, we break it into several pieces by using missiles. This way, less destruction is caused to the planet, and this will provide many little fragments of rocks from which minerals can be extracted easily. Now, since I said that less destruction will be caused, you must be wondering that be it less or more, destruction is destruction. No one wants to cause destruction to our home. So, to minimize the destruction to zero is our challenge. But how to overcome it? What if we smash the asteroid not into our own planet, but all in some of our neighboring one? So we assume that the we smash the asteroid into the neighboring planet like Mars, that is nearer to the asteroid belt, and which is also an advantage of using it as a target planet. So smashing asteroid on some other planet and collecting minerals is all. Are we done? A big no. As smashing asteroids need to be studied in detail. It can be done by increasing the gravitational field of the planet. But how? So here is the answer. Gravitational field can be increased by increasing mass or by reducing the radius of the planet. Mass can be increased by converting energy by using the equation equals to mc square, in which energy is transformed into mass, and radius can be reduced by converting lighter and abundant elements like oxygen and silicon present in the planet into dense elements like iron or nickel. So now we come across our last challenge that we can encounter during this method. That is collecting and bringing these minerals back on our own planet. So since we assume that the target planet is Mars, we can use its retrograde motion that occurs every 2 years. Since it is the time when Mars is closest to our planet, we can and it lasts for around nearly 72 days. We can use this time as the best time to have contact with Mars. We splitted the team into three parts. That is, one will be mining the minerals from the planet. One will stay in the spaceship that will be parked in the zero gravitational interaction region between the Mars and our own planet, and the third team will be on our own planet that will be collecting the minerals. So the mining team will send the minerals to the planet to the team in the spaceship, and which will further send the minerals to the third team. Since the spaceship is parked in the zero gravitational interaction region, it will not move on its own. So this method will save time, energy, and fuel that is consumed while launching the space vehicle every time. Now we can say that we are done with solution one. Now we come up with the second solution, antimatter plant. Antimatter is made up of anti-elements such as positron, antiproton, and antineutron. At the time of Big Bang, matter and antimatter thought to have existed in equal numbers, but then they hit and reacted, producing photon particles or gamma rays and great deal of energy. Cosmic microwave background is one such example. To your surprise, I would like to tell you that 10 milligram of antimatter can power around 100 tons of payload mission, 1 year mission to Jupiter. So why not use it to process? Why not use this process to generate the energy for our own consumption? We need antimatter, but it is assumed to be vanished. So what if we reverse the process? What if we use photons to produce antimatter back again? This can be done by using cosmic rays, by passing cosmic rays through high energy this electric and magnetic field. This way, antimatter can be reproduced. And to our surprise again, nature do it on its own. The biggest example is thunderstorms. In this, cosmic rays react with the planet's magnetic and electric field and produce antimatter, which gets accumulated around the planet. Since producing antimatter consumes a lot of energy, so we don't go towards producing antimatter. Instead, we work on collecting the antimatter that is accumulated around the planet. So our new challenge is how to collect the antimatter. For this, at present also we have few technologies like penning traps or low-phase trap, but these are used at very low scale. Like it is used to collect antimatter at nanoscale. So we need same technology but at large scale. We can also use plasma magnets to attract antimatter particles. Therefore, from amount of research and understanding, we propose the solution on asteroid attraction and annihilation for fulfilling the need of resources of minerals and energy respectively. Thank you and have a nice day. We are open to questions now.
Okay, so thank you for very nice talk here. So I have actually one question. The rest of the presentation has been presented very nicely. So the question is, you were talking about the asteroid, like the asteroids mashing in the other planet, for example, at Mars. Okay, and you are talking about this time, I forgot the term, when the Mars will be the closest to your planet. But what is the probability that there will be an asteroid, and how do you do the smashing on Mars? Can you elaborate on that?
Yes, sure, sir. Like we assume that Mars to be our target planet. It is nearest to it is nearer to the asteroid belt. So there is very high probability of we can find the asteroids. Like if we uh, if we use our own planet, then there is lesser probability of getting an asteroid. Like we get asteroid around like 2000 years, one asteroid we get around in this time. So we can use Mars for this. Like there will be more probability as it is nearer to the asteroid belt. once the asteroid will pass to nearer to the Mars, the gravitational field will attract it towards itself and towards the planet. And when it enters the planet's atmosphere, it will be crashed or smashed into pieces by using missiles. And this way there will be fragments of the asteroid and not the whole asteroid hitting the planet and more destruction. Instead of that, we will be smashing the asteroid into pieces. This way there will be fragments that will fall on the planet, and then we can mine those fragments.
Okay, so whenever you are talking about the missile, it means that we have to assume that there are enough infrastructure growth on this planet X, right? So, or if you start from the scratch, how do you extract the energy then? Like, for example, to have a missile, you need some infrastructure, right, or some technologies. But I understand your point, but like, for example, if we want to build from scratch, so how do you then extract the energy from the asteroid? Imagine if you do not have any missile, or something is still going on, but you need some energy resources.
Like, so for one way is letting the whole asteroid smash into the planet in which no civilization is there. So one way is that, but since we wanted like to mine the whole asteroid is very difficult thing, or so we thought of this, like smashing it into pieces will be better way. For that, if there is nothing, like we can all I can think of is like we can send the missiles from our planet to that neighboring one, or we can like uh, program it to use when there is asteroid coming into the atmosphere.
So in other way, we still have to be dependent on our planet, even though we are in the planet X, right? That is what you are saying.
No, we are on the planet X only, but while at the time we have few resources, or we have the technology that is made in type 2 civilization, that we have kind of a technology that we can use for smashing for this purpose.
Okay. Okay. Thank you. So anyone else have the question? May I ask?
No questions.
No, it's fine.
Thank you for your presentation. You can leave the meet now.
Thank you everyone.
Thank you, sir.
So next up we have Planet Exians from IIT Dhanbad. Please switch on your videos before presenting.
Am I audible, sir? Am I okay? So when should I start?
No, let's start.
Okay. Wait, let me share the screen. So, space as a resource. I think of space not as the final frontier, but as the next frontier. Not as something to be conquered, but to be explored. Not only do we live among the stars live within us. These famous lines by American astrophysicist Neil deGrasse Tyson inspires us to this day to ponder into the vastness of the space. And the human civilization is never bound to anything. So in the 24th century, we ventured out and settled onto another planet X. Now, this planet X, which is capable of hosting life, is similar to Earth in terms of its solar system. Our civilization is a type 2 civilization on the Kardashev scale. And as we reboot from hibernation after leaving Earth, we now embark on our journey on Planet X. Our first job will be to ensure arrangements of essential commodities to sustain life. We need to make arrangements for non-contaminated water and food. Luckily, this Planet X is suitable enough to provide these needs. But Planet X is scarce with energy and minerals. It can only sustain us up to a maximum of 5 years. Hence, our primary target would be to build sustainable energy resources. And now we search for energy and resources in various forms in the solar system. So the possible solutions to tackle the problem statement are uh, atmospheric extraction, nuclear fusion, Dyson swarm, and mining planets. Atmospheric extraction. One solution to the energy crisis of our Type 2 civilization will be the extraction of hydrogen fuel from the atmosphere of planets. Assuming the solar system of our Type 2 civilization and to be completely alike to that of planet Earth, it must have the Jovian planets or gas giants in its solar system. The planets falling under this category are Jupiter, Uranus, Neptune, and Saturn. Now let's talk about Jupiter. Jupiter is so massive that it can fit 1300 Earths inside it. Its atmosphere is 90% composed of hydrogen. Now, hydrogen is a very efficient fuel. Its byproducts are not harmful and gives us tremendous energy. And considering the size of Jupiter, we'll have our hands on billions of liters of hydrogen, which will let us survive and sustain for more than 1,000 years. And we are just not limited to Jupiter. We have Saturn and other Jovian planets too. Our technology will be advanced enough that we can extract fuel from these planets easily. These gas giants will act as reservoirs and for hydrogen and provide us energy. And also along the interstellar route, we can build space stations so that the astronauts in charge of the extraction process can have recreation. And also it will serve as scientific research centers. And with this, I conclude my part and hand over to my teammate Nilimesh Dwara.
Thank you, Vishal. Now, I am going to discuss another important source of energy, nuclear fusion. Being a Type 2 civilization, it will be able to harness the power of nuclear fusion. Two atoms fusing together, forming a larger atom and releasing a large amount of energy. But fusion requires a very high temperature of about 100 million Kelvin, which is about 6 to 7 times the temperature of the core of our sun. So how are we going to achieve such temperatures? Well, we can use particle accelerators consisting of superconducting magnets. The particle accelerator can be used for collision of hydrogen atoms by moving them close to the speed of light. In this process, a very high temperature will be generated that will be high enough to start the fusion process. But here, another problem arises, that is confinement of temperature. No material is known till now that can withstand such high temperatures. If the colliding atoms can somehow be teleported to outer space, our problem will be solved. So out of the many possible solutions, we try to figure out an efficient one. Assuming the civilization will be advanced enough and will be capable of teleporting objects, we thought of quantum teleportation. Quantum teleportation is an application of quantum entanglement, which is a phenomenon in which two particles or sets of particles are related by their quantum properties, such as spin or angular momentum. The particles' quantum states are dependent on each other as they form a connection. The particles are said to be entangled. A particle can be teleported if it mingles with the quantum state of either of the entangled particles. Now imagine these two particles separated by a large distance, and we introduce a third particle that changes the quantum state of the first entangled particle, which in turn changes the quantum state of the second entangled particle. In this process, an exact copy of the third particle will be created at the position of the second particle. It seems that the particle has teleported from one place to another. We can use this concept to create two chambers of particles. One will be placed on the planet X and the other will be in outer space. Both of them will be linked by entanglement. The hot plasma generated by the collision of hydrogen atoms will be scanned and it will act as a third particle, and due to quantum entanglement, an exact copy of the plasma can be created in outer space. Using the concept of quantum entanglement, we have just teleported the hot gas or plasma into outer space and we'll get a mini star in this process. We can continue adding more hydrogen to it. We can then extract the energy of the star and utilize it. It may sound too theoretical or fictional, but quantum teleportation has already been realized by scientists. Photons have already been teleported to a significant amount of distance. So if there is a high possibility that humans will be able to develop it to that extent. With this, I conclude my part of the presentation and hand over to my teammate Bhargav.
Thanks, Nilmesh. Our next solution for the problem statement is to build a Dyson swarm. Now, what is a Dyson swarm? We can think of it as a structure that completely encompasses a star and captures a large percentage of its power. Well, constructing a Dyson swarm may seem far beyond the engineering capacity, but a Type 2 civilization will be equipped with such technologies to make it possible. To construct such a megastructure, we'll need plenty of energy and resources. We're going to manage the requirements from the processes like nuclear fusion, atmospheric extraction, and mining other planets. A viable design for the Dyson swarm will be an enormous set of lightweight reflecting mirrors orbiting around the star. The mirrors will focus the light to specific points. We'll build some collecting stations around the star to capture the energy. Successfully shaping the megastructure will be a huge technological leap for us, as it is intended to capture as much as the power output of the star. This will enable the possibilities of exploration, expansion, and the odds of survival of us as an interstellar species. With this, now I hand over to my teammate Avoy for further explanation.
Thank you, Bhargav. Mining mercury for resources of Dyson swarm. Now that we have looked through the introduction of Dyson swarm, we will get to know how we will get the resources to make one. The best option would be exoplanet mining. Now, why mercury? First, it is closest to the sun, so distance will be reduced to launch the parts of the Dyson swarm. Second, Mercury's gravity is 0.378 times that of Earth, which helps the making heavy machines easy for mining and launching of parts. Third, Mercury's composition is 70% metallic and 30% silicate. The metallic component will be used as a resource to make the mining machinery and 30% silicate for making effectively large solar panels for the Dyson swarm. Now that we know why we chose Mercury, we should know how would we do it. Humans are very fragile, so every machine has to be autonomous with exceptional tolerance and efficiency. The energy required for running machines can be obtained by solar panels that we are creating. First set of solar panels will provide energy to make second set. These two sets will provide energy to make next four sets, and it will go exponentially. We can use this energy to make more mining and solar panel machinery. Now, to launch the solar panels around the sun, a gun with magnetic levitation principle will be preferred, throwing solar panels at a high speed towards the sun at a distance where it can work efficiently for a prolonged time. Now, to complete the swarm, this may take decades. We don't have that much amount of time. So, even if we just complete where we get just 1% of sun's complete output, we would be getting 4 billion terajoules of energy, which would be more than enough to sustain us for completing the swarm and sustaining our species. With this, we Planet Xians conclude our presentation, and thank you, Arka, for giving us this wonderful opportunity for presenting ourselves.
Okay, so thanks for this nice presentation. I have one or two questions. So you were talking about these nuclear fusion processes. So for example, what kind of nuclear fusion reactions you have in mind? And the second question is that you talked about the quantum like the teleportation, okay? So you said that it would be Planet X and outer space. So why outer space? So can you answer these two questions?
My teammate Nilimesh will answer it.
Yes, sir. The reaction will be between deuterium and tritium to form helium. And we are keeping the star in outer space because we cannot contain such high temperature. There no material can contain such high temperatures here on Earth or Planet X. So we are placing it in outer space.
So, but in the outer space, you also need something to contain, right? So how do you contain them in the outer space? It cannot float in space, right? So you need something. You understand my point?
Yes, sir.
Sir, the type 2 civilization will be advanced enough. They will have such technology to contain that. Like we are already building Dyson spheres. So
Yes, but
application of
then you do not need this thing for the outer space to do this quantum teletransportation to your planet X, right?
So if we do this on Earth, this could prove like experimentally devastating. So
No,
not
no,
taking
no,
any chance
no,
for
no.
humans' existence.
I am not talking about planet Earth. I am talking about planet X. So your teammate Vishal said that it is very technologically advanced. So if it is technologically advanced, then you can do this fusion reaction on planet X, not outer space. So that is my question.
So we'll not take any chance so that it can cause harm to our civilization, as it is already lacking resources and minerals. So why take a chance if it ends
Yes,
devastating?
but then my second question comes that if it is in the outer space, you need something, at least some stars or something or some. I mean, how do you then generate or how do you fuse these two nucleus? For example, you need something. It cannot fuse by itself. For example, if you put two nucleus in space, you need some kind of.
Yes, sir. As my Nilmesh already said, we'll have particle accelerators, so which will help them collide.
Yes, but then you need to build a particle accelerator outside in space.
Yes.
Sir, we are building it on the planet X, and we are colliding the particles, and we are then teleporting the gas into outer space.
Okay, so you are building the particle accelerator in planet X and you are transporting the energy to some outer space.
Yes,
but that energy you will be needing, then you will be required back this energy to your planet X.
Actually, sir, if they can leave the Earth and go for another planet X, and their type 2 civilization, they will have such technology to harness energy, means to gain energy from that.
Okay. Okay, so I am done with my question. If anyone asks.
I have one question.
Yes, sir.
Why haven't you considered non-conventional sources? You told that you have plenty of water and food there, so you can use biomass and other things. Is there any problem to consider that resources?
Oh,
So I don't think like because the biomass will be enough to provide the energy requirements for a type 2 civilization because it will be on a higher level to us. So I don't think that conventional sources will be much of a help in terms of energy.
Okay.
Questions, respected seniors.
No
other questions.
Okay, sir. So should we leave, sir?
Yes, thank you for your presentation. You can leave now.
Okay, thank you, sir.
Thank you.
Thank you, respected seniors.
So next up, we have Team Asgardians from IITS Dhanbad. Please switch on your videos before presenting.
Are we audible? Am I audible?
Yeah.
Good evening, sir. Good evening, respected CEOs. Okay. Okay. Shall we start?
Yeah, sure.
Should we introduce ourselves before starting the presentation?
No need. You can just start. No need. You can just start.
Should we start? Okay. Okay. So good morning. Good afternoon to one and all present here. So this is our project Planet X by the Asgardians. So what we have thought is since planet Earth is no more and we are now rehabilitating to a different planet, so the Asgardians are here to help you out by proposing some ideas using which the planet X can further proceed. So now we need to understand our solar system looks like. Our solar system is no more consisting of Mercury or all those planets. It now consists of different planets, and our new star near us is Altair. So now the major problems. What are the problems that we are facing? The major problems in hand with us is the metal and mineral resources. So why we are facing this is because of the contents of the crust or the mantle and the energy sources. So we lack fossil fuels, and it says that we have like a resource of like next 5 years. So what can we do for that? So we can now go for asteroids and meteoroids because we already know how good resources are they for when it comes to metals and minerals. And also we can think about like different planets, considering different planets have different types of resources. And now for energy, we can think about the star near us, Altair. Now, Altair energy can be used by us, but in different ways. First is like building a local body. What is meant by a local body? A local body here means like we use the planetary system of our own. Like we use our planet and our star. Like no, not the star. Sorry, my bad. And the satellite. And then there is the alien body construction, where by alien I mean we are using the whole planet, the whole system. Like we have the solar system, so here if we call it the Altair system, so we are using the Altair system as a whole. So let us understand what is a local body construction. So in local body construction, we are launching satellites which will be outside the atmosphere, and from there it will be receiving the sun rays directly, and it will be then transmitting the energy to us by there will be some substations. Now the question here is why we are using microwave. So like a possible solution can be using laser technologies as well. But then the orbit will be low. It will be like about 250 miles. And if we are using like a laser transmitter, it is like a 6 feet in diameter instead of several miles. So like a possible solution we can think is using the energy of the Altair and power beaming the system, employing diodes. Like generally it's based on an alkali laser. So now next we can like it's extremely high efficiency because of extremely high efficiency, and efficiency nearly is about 50% of the procedure. Now, but there are several challenges regarding this, and I think considering the fact that we are like a Kardashian scale to a civilization, so we can overcome them. Now, next we can think about is building a Dyson sphere. Now, building a Dyson sphere is not easy, but we have all the resources, but we need to think about like the metals and the minerals. Now, for that we have chosen the nearest planet to the sun. For first, because if we launch the Dyson swarm elements, then it will be traveling the least distance from the planet S for us. Now, also another reason is planet S has a core of alloys of iron and nickel. So it will provide us with metals, and we can use that. And now, if you think about the the temperature that planet is having, so considering the Kardashian 2 scale, we can understand that at this period, human civilization will be quite upgraded to have cyborgs or to have like robots who can employ those stuff. Also, now what we will do is we will make reflectors. Now in reflectors, metals are important, but we will use flat plated metals like a metal foil in such a manner that it transmits the whole thing into a single laser beam into a single point where there will be a collector and then the collector will then give it to the planet S for this. Now in planet S, what we will do is we can employ the same thing and repeat the procedure again and again to create more of the elements. Now if we create in that manner, what will happen is we will make it an exponential growth. From 1 we will powering 2, from 2 we can power 4, from 4 we will power 8, like this it will go on, resulting in resulting in that energy scarcity will be over. Now once we finish with our like this covering the whole Altair, what we can do is then we can use the energy back for Earth. Not Earth, planet X. Now, in that case, it will be quite a good way to where we can build a colony of all the planets. There are 4 terrestrial planets: Mercury, Venus, Earth, and Mars. So, in that case, here also there are 4 terrestrial planets. In those 4 terrestrial planets, we can make our own colony of planets. And if we have a colony of planets, the best thing will be we have resources from all the planets, and then we can terraform different planets to make it more suitable for our living conditions. Next slides. So as I already mentioned, like how we will be launching it. So once we are finished with the cyborg part and we take all the metals out, we will be launching it in such a manner like first one element is launched, then we will be using that element's power to power 2. So in that way, the exponential growth, and we get the enough power to supply to launch the whole thing into space, into Earth. And once it's done, we can, as I said, we can make a whole colony out of it. So next slide. So now Dyson sphere and everything is cool, but if there, is there any other energy sources we can think about? Like Dyson sphere, in Dyson sphere, I can add something like in Dyson sphere, we can also increase our computational power. It's something that called a Matryoshka's brain, where the computational power is immense. Like it's as immense that we can not think about it, not imagine about it. It can, we can use that engine to in fact go for a stellar engine, and in stellar engine we can now go to the nearest star and do the same procedure and take energy from there as well. So that's cool. Now we can move forward and talk about the magneticity. So what is magneticity? So during Big Bang, there were several magnetic monopoles that were formed. Now it was not we cannot harness these monopoles because due to the energy barrier, and currently we are not that upgraded as a system. But as Kardashian 2 scales suggest that it will be possible to harness that. And now, since gas giants and neutron stars contain a large dense of this what we call mag matter, and this mag matter can be used for powering of several things. And we have written a short paragraph. I'm not reading it out. So it suggests how good this energy can be utilized, and using this energy, we can use the whole energy for different purposes, like in Planet X. Also, since there is something called thermonuclear explosives, so this can be used in case of mining. Now we have talked about asteroids. So asteroid mining, we can use this energy up, and we need to destroy, blast things, and so we can use this energy to blast out things. And next there's dark energy. So dark energy is it's unknown for us, but it's believed that 69% of the total energy in the universe is dark energy. So if we can if we can interchange matter and energy, what dark energy actually suggests, then we can make a space-time conversion rate, and then we can use this energy out for different purposes. And this energy will be huge, just huge. And this energy can be it not only can power Planet X, but all the planets that we are having as a colony. Next slides. So now I would request Prerna to take over the next part.
As my friend told, that there are a lot of ways in which we can generate energy, but what about minerals and metal? Well, asteroid mining help us to overcome the scarcity of minerals and metals that we have in our planet X. First, we need to select the asteroid and then test the asteroid if it is suitable and economically advantageous. This can be done using sample test or AI. AI recognition tool can access the surface images and predict the possible metal. Then AI-supported statistical data is prepared and processed so as to understand the economical feasibility of the project. We can also launch electric space aircraft, and in this aircraft we can equip cyborg who can help us in carry out the task. Now, what do we do after we get the right asteroid? We will stop the asteroid from spinning. This can be done by vaporizing the material from a laser or by stopping thrust. We can also apply force in a proper direction and precise timing so that we can move a very big asteroid with a very little force. And the force should be in the right direction so that it brings it near the asteroid, near the T, and T's gravitational force also helps a lot of also plays an important role in this process. Now we get into the process. The space mining and processing equipment has been installed in the orbit. Giant mirror focuses the sunlight or the light we get from Elter and heat up the asteroid. Rock boils out the gases. Grinders break up the dried rock into gravels, and dust and centrifuges separate the dense from the lighter element.
Your time is up. If you may wrap up, please.
Okay. Now bringing back the resources from X. Now there are a lot of ways to do that. First is by loading it into spacecraft, and the other is by using the space elevator, which we can create to reach the orbit of the asteroid. so that it helps in transportation and save our fuel as well. And with this, I would like to end our presentation.
Here I have only one question. So, for example, you talked about this planet X, but according to the problem, this planet X doesn't lie in our solar system, but some other solar system, right?
Similar to ours.
Yeah, similar to ours. So now the question is like, if you depend on like something on Earth, let's say on these energy resources, so how much practical point of view the humans can be transporting between these two solar systems, imagining that you require almost, let's say, 7 to 8 months of, let's say, of journey.
Sir, sorry, sir. Can you just rephrase your questions? I
Yeah.
didn't get it.
Yeah. So my question is that this planet X stays into another solar system, right?
Yes. Yes, sir.
So given the fact, let us assume that this solar system is like it's some distance from our solar system.
Yes, sir.
Okay, so we know now, like if you launch a rocket or send a satellite to Saturn or let's say Mars, how much time it takes.
Yes, sir.
But if you depend on some resources on Earth, how much practical point of view in terms of the time scale one can go back and forth from Earth to planet X in some other
So practically speaking, if the energy, like if we somehow reach planet X and we get the proper, like I said, Altair's energy using Dyson sphere, so it will be a matter of like just some hours if we get the energy, like considering the distance of how much light years it is. But if you're talking about like we have the current resources and we are currently a Kardashev, like it's not zero, it's not one or even, I think 0.75 Kardashev 0.75 scale on we humans are currently. So we are not feasible for going even outside Earth. Like we are not even ready to go to Mars and harness their, like go for there. So if humans are not eligible, robots are obviously are. So if you are asking that how we will go there, so we cannot like I said, considering 0.75 Kardashev scale, we cannot go there. But once we reach there, I suggested it's Kardashev 2 scale, and we can use the energy of the nearest star. So we get enough energy to reach to come back to Earth.
Sir, we can also use, if we are depending on Earth for our resources, though it is not practically beneficial for us, but we can also use spacecraft and a hibernation technique for doing that.
Okay. Okay. Yeah.
So did I make my, like, did you understand what I wanted to
Yes,
tell?
yes.
You in the slide you mentioned T. What is that T?
T is basically the subsequent of moon. You can check, just show that for the second slide, I guess. T is a subsequent of moon, like it's moon for us. So I thought of, basically what I thought was, since we are using not using Earth and using alphabets instead, so I thought of naming the whole thing using alphabet and naming the sun alphabet plus letter, combining that as Altair. So that's the nomenclature procedure what I thought about.
Okay, my last question is what you are going to do with the asteroid spinning?
Asteroid spinning, like what we are going to do after we stop the asteroid spinning.
What is the benefit of asteroid spinning?
What benefit are we getting by stopping the asteroid spinning?
Yeah.
Okay. So Prerna, would you like to answer or shall I answer?
You go on.
Okay, so basically, so see, if we do not relocate the asteroid and like keep it where it is, the problem is transportation problem. Now, if we bring it, like if we stop it from spinning and bring it near to the T, that is our moon, like moon for our case. So what will happen is we have talked about a space elevator or even transportation will be feasible. But if the asteroid is not in our range and we have to bring resources from there, it's not feasible for us to go. Now, as I said, by stopping the asteroid spinning, we can now relocate the asteroid. Relocation becomes easier.
Okay, fine.
Is it?
Yeah, there are no more questions. You can leave them.
Okay, thank you, sir.
Okay, sir, thank you.
Thank you, sir.
So next up, we have Team Matryoshka Brains from IIT Dhanbad. Please switch on your videos before presenting.
Good evening, sir. Good evening, seniors.
Good evening, seniors.
Good evening, seniors.
Yeah, please start your presentation.
Good evening, respected seniors. We are Team Matryoshka Brains. I'm Ananya.
I'm Abhinav.
I'm Vaibhav.
So basically, understanding the question, from the question, what we can infer is that the main problem we will have here are the scarcity of the resources, the adaptation according to the new habitat, the short stretch of time that we have to cover, the lack of settlement area, and the interstellar travel that we have to accomplish.
Now that we have seen the problems that can occur for a Type 2 civilization, but we need to understand first what actually is a Type 2 civilization. Kardashev scale categorize civilizations into three categories. Type 1 civilization can harness all the energy of a planet. Type 2 civilization can harness all the energy of its solar system. And Type 3 can harness all the energy of a galaxy. Here, we will try to see things as a Type 2 civilization.
Now back to our question. With only 5 years worth of resources left, how do we plan to survive as a civilization? We focused on two methods: increasing the survival time in the same stellar system, or rehabilitation and resettlement of the maximum population of our civilization as our extreme approach.
Now that we are talking about a Type 2 civilization, everyone who's anyone in the space field has heard of the Dyson Sphere, or the more popular version, Dyson Swarm. What is a Dyson Swarm? Dyson Swarm is an extraterrestrial constellation of man-made satellites in orbit around a star. It is the ultimate source of energy, a seemingly infinite well of pure stellar energy that will essentially power everything we do henceforth, like power the mother computer of gargantuan computational capacity, Matryoshka Brain, help to disassemble ideal neighboring planets for ores and minerals, production of self-replicating AI bots to be employed for the food production, mining, and star hunting. These were the goals of making a Dyson swarm, but how do we make one? We would need to gather new minerals having very high density which can withstand the massive gravitational pull of a star. Number of collectors will be made and be launched through an electromagnetic railgun-like structure from a nearby planet of the star. Each collector would function as an individual unit, not relying on other units to work. The Dyson swarm can be built incrementally every set, making it easier for the next. It can even be finished in less than a year, estimating 307 days.
So first we need to figure out how to use our resources efficiently to buy us some time. From the eye of an inhabitant with scarce resources that will barely last them a few years, planets are enormous volumes of mass, gifts that keep giving. First, let's consider rocky planets. The main obstacle here would be to overcome its gravitational pull. For this, we use one-Newman swarms, which are self-replicating spacecrafts and probes. We begin by locating M-type asteroids with low gravity and deconstruct them to create a swarm of von-Neumann probes and processing space stations. Then we send a batch of them for a geochemical survey of the target planet's lithosphere and distribute the probes accordingly. Next, we harvest the materials and start with building power plants, processing facilities, factories, expanding outward and onward. For transportation, we make use of rail guns or coil guns, hurling the bundled resources in launch vehicles. Finally, we intercept the bundles at the apogee with orbiting stations, redirect them to orbiting shipyards. A slower alternative would be gas giants with their dense upper atmosphere, rich in easily accessible resources. For this, we may arrange arrays of orbiting scoop ship infrastructure. We bring the ships through the atmosphere for material extraction, then release them on the aphelion of the orbit. The material can be processed on board the ships or sent to a local orbital facility for processing.
The next method, while sounding sort of outrageous, is a brilliant idea proposed by Roger Penrose in 1969. In the eponymous process, he understood that you may need to move at light speed to stand still in the ergosphere of a black hole, but you don't need to be moving that fast to enter it. Imagine that you slip into a whirlpool. Instead of just floating along for the ride, you start paddling in the direction of the water. Obviously, your speed would dramatically increase more than you could normally swim. Eventually, you would fall into the center of the whirlpool, as you would in a black hole. If you could leave something behind, however, you may be able to escape. In theory, a rocket fired into the ergosphere could separate into two halves. One half would fall into the black hole, but the other could launch out of the ergosphere far faster than it entered. Sound familiar? You might have seen this in Interstellar. We can use this to our advantage. Essentially, a giant mirror, not unlike the Dyson swarm, could be built around a black hole. Once this structure is in place, we would need to open a section and shoot electromagnetic waves inside. After closing the opening, those waves would bounce around faster and faster. This leads to a process known as super radiant scattering, which is basically when similar waves interact coherently and become exponentially stronger. By opening another panel, these waves could be absorbed and converted into massive amounts of energy. With this, our Type 2 civilization has another seemingly infinite well of energy in the bag.
Fusion reactors. Fusion reactors are theoretically infinite power supply as they use plasma reaction in a confined space imitating as that in the sun. They continue the process of creating and supplying energy at a rapid rate with stabilized plasma. I'm sure you all have seen Tobey Maguire's Spider-Man 2. In that, Doc Ock was running wild in the town in search of tritium to harness the power of the sun. Well, that's the main concept of fusion reactors. They use tritium as a battery to perform fusion and fission to make a little sun of its own. These reactors are really helpful in interstellar travel because they are energy efficient and are even small and easy to carry from one place to another when placed in a stabilized tube. With human modification, the same would help in food supplies too, as this energy could be consumed by the bodies.
These little beasts, serving as the power source of the craft, will prove to be the lifesaver in the evacuation phase. The fuel for running them, that is tritium hydrogen, is abundantly available in the stars. Hence, these ships capable of long maneuvers will need to stop by any nearby star for a recharge, and that too for a short period of time. Now, next to the O'Neill cylinder. Roughly, it is the idea of settling on man-made cylinders orbiting the star, given by physicist General K. O'Neill and improved by many, has much more into it. The structure comprises of two large counterclockwise rotating cylinders, will be a home for the people of aforementioned advanced civilization. With the environmental conditions replicating those of the habitable planet, artificial gravity, simulated day and night, genetically engineered forest covers. The main advantage of this model is that it doesn't need the material from the home planet to construct it. Rather, all the material would be at hand, from mining asteroids for metals to using their hollow shell for making the cylinders. This can also act like space buses for spreading humanity further in the galaxy.
Terraformation. Terraformation is the process of deliberately modifying temperature, atmosphere, surface topography, or ecology of a planet or other habitable bodies like few asteroids and moons. Well, this is the literal definition. But what it actually means? It means we can completely modify a planet or asteroid or moons to a completely habitable place where life can exist. To a type 1 civilization, it's limited to its own planet, but we are here with a type 2, which open up more options. We can scatter the population to the neighboring planets of the stellar system of Planet X to reduce the resource consumption of a single planet. Terraformation can also help in moving from one stellar system to another, where we can modify the planets in the habitable zone of the respective stellar system according to our needs.
Well, wandering around the space with an empty stomach is not a good idea. We need food resources. So, how will the food production be tackled? The answer is space farming. We can have robot-assisted farming on nutrient-rich asteroids and moons by making bunkers and geo-engineered domes. We may even geo-engineer the host planet for maximum food production. We may do biomodification of human body for reducing food and water intake. Doing all these will extend our time of survival on the host and for further technological advancement.
Human modification. Human modification is the concept we have all heard in many fictional books and movies like X-Men and the Matrix series. This is really a vast concept in terms of biology. But what are its significance in astronomy? With human modification, we can change humans or any other species bodies into ones which can endure long distance and long term space travels without much problem. For example, we dream of traveling with speeds comparable to speed of light, but our bodies are technically incapable of those at the current rate. We humans, with human modifications, we can make our bodies capable of this and even more things like surviving on energy resources other than food, regeneration capabilities which could in case of which could help in case of damage in interstellar travels.
And this was for our take on the question. We are Team Matryoshka Brains, and thank you.
Yeah, thank you for this nice presentation. So I have only one question. So, for example, you talked about this black hole and building up the Dyson sphere close to it. So, how are you making sure that it will be in the, I mean, it will be in the ergosphere, not falling into the, I think, the black hole?
Sir, sir, can I answer?
Yes, sure.
Sir, basically, black hole is nothing but a star whose gravitational pull is so enormous that the light cannot exit it. So, if we, for the point of view of a star, nothing will be able to enter the black hole unless it is right centered towards its core. It will only slingshot from the side.
Okay, so like you will be in the ergosphere, like outside
Yeah.
where.
Yes, sir, outside the region
Outside
of
the event horizon.
event horizon.
The
Okay,
ergosphere. That way.
so now, so
Sorry.
now if I mean, according to the problem, so for example, this solar system where this planet X like lies, it is the similar solar system to our solar system, right?
Yes,
So
sir.
now if you consider our solar system, which lies in the Milky Way galaxy, and the solar system is in one of the spiral or one of the legs of
Yes,
this,
sir. Yes, sir.
and this black hole is really at the center. So
Center.
yes, so how are you then making up this one for your planet X? Like how possible? Like let's say you, I mean, you build a Dyson sphere, but imagine that you have a similar scenario as our galaxy. So what could be your like the solution for such a this?
So we can go with artificial black holes. Like we are going with researches in artificial black holes, and we have discovered many minute and different scenarios in the same our galaxy near different stars where we can spot us disruption. Like we can tell a black hole is being created or something. So we can
So
just
if you talk about the artificial black hole, first
yes.
of all, it is not a matter of joke to create an artificial
Yes,
black
sir,
hole, right?
exactly. It's not so simple, but hypothetically, we have been studying
Eventually,
on.
yes, eventually, hypothetically, it is very difficult. Well, in this movie, I forgot the name of the movie. There was building up this black hole. Uh, just help me with the name. It's like Angels and Demons, maybe.
I
Uh,
don't remember,
e-
sir.
so it's a quite old movie where they are creating this black hole, but I don't think it is possible. But hypothetically, everything is possible. Yes.
Yes, sir.
Okay.
And sir, also, even if the black hole is that far, we also mentioned fusion reactor engines and also interstellar travel. So, black hole project of like making the black hole galaxy center black hole is one of the future kind of projects, even if we have to, because it's extra energy. So, I think that would
Yes,
also
we can
happen.
just take all scenarios in mind. We have many, like, if one thing fails, we can always go to the extreme end of our ideas.
Like these are the our footing steps for the type 3 civilization part. Like this is the extremes of the type 2 civilization that we can reach for controlling the black hole part.
Okay. Okay. Thank you.
Do you?
Sir,
Thank you, sir. Thank you, seniors.
thank you, sir.
I have one. I have one question.
Oh,
Okay.
sorry, sir.
Uh, have you also planned up for setting up any how we are going to establish a communication system? Anything because you will need communication to do all these operations, right? So,
Yes, sir. We have not thought about that yet.
okay. Okay, fine.
Okay, so we leave now.
Yeah, can leave the meet.
Thank you, seniors.
Thank you, seniors.
Thank
Thank
you,
you, sir.
seniors. Thank you, sir.
Thank you, seniors. Thank you, sir.
So next up, we have Team Vision from IIT Dhanbad. Everyone, please switch on your video before presenting.
Hello, am I audible, sir?
Yeah. There are 4 members in your team, right? So where is other one?
Uh, yes, sir. He would be joining soon.
Yeah, you can carry on. We will wait him for now. You can start your presentation. We are lagging behind the time.
Yes, sir. Sir, may I share the screen?
Yeah, sure.
Good evening, seniors. Sorry. Good evening.
Good evening, sir. Good afternoon, respected seniors. Firstly, we would like to express our gratitude for giving Team Vision this opportunity to express our thoughts on this topic. So to start, we'll summarize our problem statement for the first part. So unfortunately, we have to leave the Earth since it has become uninhabitable. We have to settle at a planet X where the resources are enough to sustain us for 4 to 5 years. We are a type 2 civilization, hence we use space as our resource provider. So after a civilization lands on a planet, the two main obstacles for surviving becomes number one, fulfilling its resource needs, and number two, fulfilling its energy needs. During our research for this topic, the most appropriate solutions we derived were for our energy requirements, a Dyson sphere, a black hole bomb, and nuclear fusion using He3. And for our mineral requirements, extraterrestrial colonization and asteroid lifting. Now, my friends, Shivam and Aditya will elaborate on these topics.
So coming to our first and most effective solution, the Dyson sphere. Dyson sphere is basically a hypothetical megastructure to be built around the main star of the new solar system, as it would be the prominent source of energy in the entire system. As only a fraction of stars' radiated energy reaches the surface of our planet X, the basic function of this Dyson sphere would be to trap all the energy radiated by the star and use it to empower our civilization. In order to do so, first, we have to take some precautionary measures in order to ensure maximum efficiency and minimal efforts and damage. Firstly, we would have to ensure that our solar collectors align themselves accordingly and keep on rotating around the star so as to overcome the star's gravitational pull and prevent the structure from collapsing into the star itself. Secondly, as we know, these stars generate energy equivalent to a trillion nuclear bombs per second. Hence, there would be a need to develop proper storage facilities for all the energy that is absorbed. Construction of a Dyson sphere can be categorized in 6 simple steps. First is get energy for building the basic structure of the sphere. Second would be for resources, we can mine the planet closest to the star as it would require less fuel and energy for transportation and alignment for these collectors. Next series of steps would actually be to build, design, and adjust the structure around the star. And last step would be to recheck all the functions and start extracting energy from it. And another way to harness this immeasurable amount of energy can be through a black hole bomb. Harnessing energy through a black hole bomb is even a challenge for Type 2 civilization, but not impossible. As we know, in space, the angular momentum is always conserved. So when a star turns into a black hole, its size decreases. Hence, the rotation speed of the black hole increases exponentially. So the basic concept of a black hole bomb is to use that high speed of the spinning black hole in order to increase the kinetic energy of the object and then harness that extra kinetic energy for our use. We would fire a beam of electromagnetic radiation into the ergosphere part of the black hole, where the space time continuum is not completely ribbed. It will be fired at such an angle that it enters and then leaves the ergosphere, but with higher kinetic energy. We would also build reflecting panels around the black hole so as when the emitted beam can bounce back and then repeat the process all over again. By this method, we can increase the energy of the beam exponentially and that too within seconds. Once at a required energy level, we can release the beam and we can trap and harness its kinetic energy to empower our civilization. Now my teammate Aditya would continue.
Uh, I would be continuing with energy production with nuclear fusion. Nuclear fusion is the future as it produces massive amount of energy without any toxic substances produced. That's why it is the cleanest power source for us. It can even be used remotely so that can help us in our early stages of colonization. We can use helium-3 as a fuel for generating power for the fusion reactor. We can mine it from other planets of our solar system if not found on planet X. Extraterrestrial colonization to the planets and asteroids. Our planet has very limited resources, so to counter it, we would need minerals and metals which we can import from other uninhabitable planets and satellites with the help of rovers and probes that will extract the elements and send it to our planet. Asteroid lifting. In this, we will deorbit mineral-rich asteroids from its orbit and embed it to the orbit of our planet so that we could work with it at ease. Psyche 16 is an asteroid between Jupiter and Mars, which is worth more than the whole human economy. So exploiting such things can help us coping up with our problems. So next slide. Firstly, a spaceship will go towards the targeted asteroid and stop its rotation with the help of high tensile cords wrapped around the asteroid and the thrusters of the spaceship. Secondly, it will get attached to the rock and push it in such a manner that its trajectory gets embedded to our planet orbit. Thirdly, we will send the extraction tools that will take out the good stuff from it, and it will throw the elements to our planet in the water bodies in large capsules, which we would collect manually. Now, my friend Vedant will conclude.
Okay, so that brings us to the end of our presentation. I'd like to summarize by saying that being in 2022 and utilizing a vast inventory of resources already, we must think about the future. That how are we going to satisfy our energy needs? As we are zero point 0.7 on Kardashev scale, so we need to explore more for energy requirements. Thus, we must invest most of our time and efforts in exploring our planets so that when the need comes, we shall seek ambitious and extraordinary measures to get through. There was a famous quote by Albert Einstein that logic will take you from A to B, but imagination will take you everywhere. And okay, so here we conclude. You can ask questions or share thoughts about the presentation. Thank you.
Yeah, thank you very much for this nice presentation. I have only one question about this asteroid. Can you share the screen, please?
Yes, sir. Sorry.
Yeah, about this asteroid lifting in the previous slide, maybe, where you demonstrate, no, where you demonstrate how do you put a tensile cord, yes, here. So after you put this one, how do you put it into the orbit? That was not clear to me.
Actually, I would like to take it. Actually, the spaceship will get attached to the rock, and with the help of thrusters, by calculating it, and the spaceship would be aligned to the center of mass of the asteroid. So, with the help of thruster, a little push can help it to deorbit from its orbit, and then the trajectory will lead it to our Earth orbit, and then it will get attached to the orbit of our Earth. Sorry, not on our planet.
On the planet X, so it will move into the same orbit as the planet X?
No, it will revolve around our planet.
It will revolve around the planet. But how do you then determine like the new orbit then? Or what is the safe distance that it will, you were saying that it will be revolving around the planet X, right?
Yes, sir.
Yes. So then how do you calculate such safe distance so that this asteroid doesn't smash on the planet X?
Um, so we would be calculating it, like at that point of time we would be able to, but for now I can tell it won't be very near to our planet. Like it would be way above, like the ISS we have, more above it. Like it won't be anywhere around the atmosphere of it, because the asteroid may get vaporized and we won't be able to extract the elements from it.
Okay, thank you.
Have you planned to use some of the energy of your sun in the system?
Yes, sir. That's what the Dyson sphere was about. Like, we are planning to use the energy of the star of the solar system to harness the energy.
And what about the other non-conventional sources, like about geothermal energy? Have you considered, or do you think what will be the cons of that non-conventional other sources?
Uh, Sir, we thought that using Dyson sphere and that black hole bomb, we would be having enough energy for powering our machines. So I
Okay.
I don't think we would require any non-conventional method after that.
Okay, fine.
Any
Okay, so
more-
I don't think there are any more questions.
Yeah.
Thank you for your presentation. You can leave the meet now.
Thank you so
Thank
much.
you, brothers.
So next up we have Team Cosmo Rovers from IIT Dhanbad. Please switch on your videos before presenting.
So shall we start?
Yeah, you can start.
Yes, you can.
Pranjali, please present the screen. So, good evening, respected judges. We, the team Cosmo Rovers, are here to present our views upon resolving the issues of deficiency of resources faced by Planet X. As mentioned in the problem statement, the civilization being a type 2 on Kardashev scale. Let us first understand what Kardashev scale really is. In most precise words, Kardashev scale is a measure of civilization's progress based upon its energy consumptions. And in order to harness energy from varied resources, technology plays a vital role. And so, technological advancement is an aspect of it. Based on this scale, a type 2 civilization is one that controls and utilizes energy of its entire solar system, its star being a major source. Being a type 2 civilization, we are technologically advanced, but at the same time, bounded materially and energetically. Now, let me take you through our roadmap to overcome these foundations. The very first step being astro mining, which will vanish any and every material limitations faced, followed by the stepwise development of Dyson swarm, which will empower the civilization with abundant amount of energy. Now, with surplus amount of energy in hand, we plan to establish interplanetary base stations, which will further help us in future research work. Now Deva will give you a close look to astro mining.
Astro mining or asteroid mining is the exploitation of minerals from asteroids
and other minor planets. In our problem solving, astro mining is our primary step. As we are considering ourselves to be type 2 civilization, we'll consider ourselves to be technologically advanced enough to use this method. Our idea behind astro mining is to extract metals and minerals from the appropriate asteroids, hence to decrease the scarcity of resources faced by the planet X. Also to be noted that astro mining requires minimal energy and resources, which is right now provided by the planet. These resources extracted will be then used to develop Dyson swarm, hence to solve the energy scarcity. We can break down this method into three broad ways: selection, expedition, and extraction. Selection. With the help of appropriate AI mechanism, the asteroid will be studied in order to detect the most profitable one. The AI will also consider fact that the extraction from them should be efficient enough. Expedition. For expedition, we'll be using fuel-efficient electrical space probes. These probes will be sent to our asteroid and it will use the appropriate technology to extract the required material. Extraction. After the successful landing of the probe, the robots will start the mining process at relevant sites. After extraction, these materials will be then sent to the planet. The next step for our problem solving will be building up the Dyson swarm, step by step, which will be now explained by Pranjali.
With the problem of with the deficiency of metals and minerals solved by asteroid mining, we will now move towards energy, which we plan to fulfill by Dyson swarm. But why do we need it in the first place? Only a tiny fraction of a star's energy is originally absorbed by the planet and can be used. So it requires a megastructure like a Dyson sphere to encompass the star to get a large power output from it. But we will be using Dyson swarm, which is a more efficient variant of Dyson sphere. And another main reason of using it is because we can send it in groups so that the problem of limited energy and resources can be solved. Head starting to Dyson swarm. Due to limited energy resources in the beginning, we will send only a small group towards the sun's vicinity, which will capture the energy and then send it back to us, which we will then use to expand the Dyson swarm and for our planetary usage. Now, how can we create a Dyson swarm? First step is manufacturing, where units will be manufactured with the help of materials collected by astromining. Second step is expedition, where the manufactured unit will be sent to the star's vicinity to collect the energy. Third is collection. The units will collect energy and send it back to us on the planet X. And fourth is expansion, where the energy collected from the units will be used for both planetary consumption as well as manufacturing and sending more units. Now I would like to hand it over to Vibhu, who will conclude the solutions we have given to the problem statement.
The gist of our presentation is that our missions of astromining and developing Dyson Swarm will strengthen our civilization both materially and energetically. The plans of establishing interplanetary base stations will further pave way to obtain terraforming. And once we start deriving cosmic energy, we can make our small attempts to being a step closer to Type 3 civilization by extracting energy from interstellar sources. That's all from our side. Thank you.
Thank you.
Thank you, judges.
Thank you, judges.
So why do you need to move to closer to the sun to get the energy? Like you said that this Dyson swarm should be moved to the sun, like at least closer to the sun.
To get better energy, because the farther we are from it, the more energy is lost in the space.
But in order to go closer to the sun, you need also some kind of technological advancement to withstand such heat.
So we are assuming
Indeed,
it's a
sir.
time.
We are considering
Let
ourselves
me.
to be yeah.
May I answer this, please? So indeed, we can this space probe. As far as I remember, Parker space probe by NASA. It has been closest to the sun, and it utilizes carbon-based shields which are heat resistant, and they protect our space probes from. They give a lower temperature to our space probes, which will indeed help us to getting more closer to the sun. And as we type to civilizations, indeed we'll have much more higher technologies.
Okay.
I guess it's close to answering that.
Okay. Okay. Thank you.
Thank you, Jess.
Thank you.
Thank you.
So there you can leave the meet. There are no more questions.
Thank you.
Okay, thanks.
So next up, we have the last team for the day, Space Explorers from IITS in Dhanbad. Everyone, please switch on your videos before presenting.
So, sir, wait for 1 second. One more member is joining.
Yeah, okay.
Okay. So shall I present, sir?
Yeah, you can start.
Okay.
Okay. Good evening, respected judges. Myself, Priyanshu Raj, and my team Space Explorers welcomes you all to the event Polaris. In this event, we want to know how Type 2 human civilization will survive in a planet where they have 5 years of human resources. So without further ado, we shall take you to the presentation our team has made for this event. Next slide, please, Revant. So now, before we get deep into Polaris, we should know what Kardashev scale is. It is a method of measuring civilizations of level of intelligence and technological advancement based on the amount of energy it is able to use. It was the measure proposed by the astronomer Nikolai Kardashev in 1964. This scale is hypothetical and completely based on the consumption of human energy. The Kardashev scale has designated into 3 categories. Type 1 is the civilization, which is also known as planetary civilization, in which the people use their energy available on its planet. The second category is known as Type 2 civilization, also called as stellar civilization, in which the humans are able to control the energy interplanetary or the solar system in which they are surviving. The Type 3 civilization is called a galactic civilization, where they have the control over the energy of different galaxies. So, after we as we have no more energy still found past intergalactic, so Kardashev never proposed Type 4 civilization. So, in the next slide, we have our 3 topics in which our team has presented our survival experience. The first topic is the conservation of available resources on the planet. The second topic is development of technology. And the third topic is what will be the results and the consequences after we'll be living in different planets in the solar system. For the first topic, I would like to bring up Mr. Amit Utkarsh to throw some light on it. Thank you.
Yes, Amit, do you want to say something?
Are you facing issues? Okay.
Yes, sir, he has poor internet connectivity over here. Relax.
Okay, no problem, sir. Then can I present his part?
Yeah, sure.
Yes.
Yeah, okay. So is it visible?
Yes.
Okay. One second. Yeah. So our first main topic is conservation of available resources on the planet. So under it, the first subheading is advanced monitoring system for a clean and sustainable biosphere. So in this, with the help of environmental monitoring, we can monitor and control partial pressures, maintain total pressure, maintain temperature and humidity of the planet. And in under the atmospheric management, we can produce oxygen, we can remove excess carbon dioxide from the other planets to establish a colony there. We can have filters for particles and microbes of the other planets, remove volatile organic gases, and distribute cabin air. And under water management, we can recycle wastewater, store and distribute potable water, use recycled water to produce oxygen. Then our second part is ocean wave energy utilization. In this, I would like to talk about the deep ocean mining. Deep ocean mining, or the planet ocean, contains a large amount of deuterium and lithium and other primary energy fuels and minerals like manganese, sulfide, nickel, copper, zinc, etc. The majority of proposed deep sea mining sites are near of polymetallic nodules or active and extinct hydrothermal vents at 1400 to 3700 meters below the ocean surface. The vents create globular or massive sulfide deposits, which contain valuable metals such as silver, gold, copper, manganese, etc. The deposits are mined using either hydraulic pumps or bucket systems that take ore to the surface to be processed. Hence, mineral and fuel shortage can be overcome with the help of this technology. Now, I would like to talk about the development of technology. Under this, our first uh, topic is terraforming. So, it is the hypothetical process of deliberately modifying the atmosphere, temperature, surface topography, or ecology of a planet, moon, or other body to be similar to the environment of Earth to make it habitable by Earth-like life. The study shows that uh, photosynthetic organisms, the melting of the polar ice caps, and the introduction of greenhouse gases could all be used to create a warmer, oxygen and ozone-rich atmosphere on some other planet to make it Earth-like. As described by Haynes, terraforming begins with the seeding of a planet with microbial life, which leads to condition approaching that of a uh, primordial Earth. This is then followed by the importation of plant life, which accelerates the production of oxygen and culminates in the introduction of animal life. Other method includes using large orbital mirrors that will reflect sunlight and heat the planet's surface. Greenhouse gases producing factories to trap solar radiation, smashing ammonia-heavy asteroids in the planet to raise the greenhouse level. Our second topic is Dyson sphere. A Dyson sphere is a mega structure that completely encompasses a star and captures a large percentage of its power output. Because only a tiny fraction of a star's energy emission reaches the surface of any orbiting planet, building structures encircling a star would enable a civilization to harvest far more energy. Other variants of Dyson sphere include Dyson swarm, Dyson bubble, Dyson shell, Dyson net, etc. Dyson swarm consists of a large number of independent structures, usually solar power satellites and space habitats, orbiting in a dense formation around the star. This construction approach has advantages. Components could be sized appropriately and it can be constructed incrementally. Various forms of wireless energy transfer could be used to transfer energy between swarm components and a planet on which we are colonized. Then Dyson shell is a uniform solid shell of matter around the star. Such a structure would completely alter the emissions of the central star and would intercept 100% of the star's energy output. Such a structure would also provide an immense surface that many envision would be used for habitation if the surface could be made more habitable. Our third topic is atmospheric mining and gas giant utilization. Gas giants like Jupiter, Saturn, Uranus, Neptune are primarily composed of hydrogen and helium. These elements can serve as nuclear fuel. Since one of the greatest achievements of a Type II civilization is the complete control over nuclear fusion technology, hence the civilization of such enormous amount of hydrogen and helium from these gas giants can help the civilization to overcome the fuel shortage. Various atmospheric mining methods include aerostats. An aerostat would be a buoyant station in the atmosphere that gathers and stores gases. A vehicle would transfer these gases from the aerostat to an orbital station above the planet. Second is scoopers. A scooper would be a vehicle that gathers and transfers gases from the atmosphere to an orbital station. Third is skyhook. A skyhook is similar to a space elevator. Such a device would be used to pump gas to an orbital propellant depot. Then there is cruisers. A cruiser would be a vehicle in the atmosphere that gathers and stores gases. A smaller vehicle would transfer the gases from the cruiser to an orbital station. Our fourth topic is asteroid and comet mining. Scientists know a lot about what asteroids contain. Astronomers use telescopic spectroscopy, which analyzes light reflected from the asteroid surface to find out what might be there. In addition to iron, nickel, and magnesium, scientists think water, oxygen, gold, and platinum also exist on some asteroids. Water interests space explorers mostly because it could help keep a space colony alive. Without water, there is really no way to move forward with human exploration of space. Comets contain a large amount of water. Water could also be broken down into hydrogen and oxygen to form rocket engine propellant. The metal ore of the asteroids could be mined and used for building spacecrafts and other structures for a space colony. Asteroid
Your
and
time
comet.
is up. If you can wrap it up quickly, please.
Yeah. Then the fifth point is star lifting, and in star lifting, we use a dead star's energy, gather it with the help of magnetism and dipole moment, and collect it and use on the Earth's civilization. And then we have biological mutations, which will be told to you by Sarfraz.
Hello. A biological mutation. Obviously, while living on another planet sounds fun, it can have several implications on our human body. Our body can go through various mutations and we might evolve in new species in 1,000 years. So, effect of gravity. Gravity affect many part of our body as our age. It compresses the spine, contribute to poor blood circulation and decrease your flexibility. The gravitational pull also affect our organ, causing them to shift downward away from proper position. Thus, different planet have different gravity and would lead to change in above features. The second issue can be effect of solar radiation. Excessive exposure to sun is known as associated with increased risk of various skin cancers, cataract, and other eye diseases, as well as accelerated skin aging. It may also adversely affect people' ability to resist diseases. Thus, excessive exposure to solar radiation on different planets can lead to above said things. Next slide, please. Inside a type 2 civilization is also is already explained by my friend Priyanshu. So I would request Revan to next slide. Conclusion: we had to leave Earth due to our mistakes like global warming, pollution, overpopulation, war, etc. We have gotten a second chance and we cannot repeat this mistake again on this new planet. We need to conserve this biosphere of this planet and avoid pollution and global warming here. We need to creative and innovative and make use of space as resource to its fullest. At the end, bring us to end. I'd like to thank you for your time and attention today. Thank you so much for your interest and attention.
So thank you for this nice presentation. Would you mind to explain that you have said several processes, like how to be self-sustained. So what is the most efficient way, in your opinion, that you can sustain in the planet X?
The most efficient way would be not to overuse and waste the available resources on planet X, as well as use various new technology like Dyson sphere, asteroid mining, star lifting, terraforming, etc. To gain more energy. So we need to use space as a resource and
Yes.
new technology so that our own X planet's resources don't get wasted, and we can survive on that planet for a longer
That
time.
I have understood. But my question is that among all the different methods that you have pointed out, which one, according to your opinion, would be more efficient, the most efficient?
Most efficient would be Dyson sphere because star has enormous amount of energy, infinitely large, so we can use that energy to colonize different planets of that solar system, new solar system.
Okay, but imagine that like the stars will also have a lifetime. Okay, this lifetime is sufficiently long so that we do not see the end state of the star. But imagine such a hypothetical way that the star has a short lifetime. So then your Dyson sphere concept will no longer exist, right? Or you cannot get enough energy. So then, according to your opinion, what will be the second efficient?
So maybe asteroid mining and gas giant utilization will be the best in our opinion. As asteroids are all everywhere in the space.
But like
can
the
use them as
question then
resource.
arises that if the star in the central solar system dies, whether the planet will survive or not. So,
Sir, can you repeat the question again?
I mean, if this, like for example, in our solar system, if the sun dies, then any planet can survive, or this, I mean, the whole solar system will not exist, right?
Yes.
Or
Yes, sir.
yeah, so then it will be a catastrophe. Anyway, thank you for your.
Sir, actually, we can use star lifting as a method from the neighboring solar system of planet X. So if some star is dying, then with the help of star lifting, we can get enormous amount of energy. We can capture it with the help of magnetism and dipole movement, as I had explained in the slide,
But
to extract that
imagine,
energy. That
yes,
would be
but
enormous energy.
But that kind of energy harvesting is fine for the technological point of view. But imagine that if you want to build a colony in planet X, then you also need to think from the agriculture point of view, and the agriculture cannot sustain without the sunlight, or what is the source of the photosynthesis then? Okay, you might build up some alternative like the light sources from that world, like from the energy, like or from the star lifting, that you can think about in that way.
Actually, sir, for Kardashian type 2 civilization, actually bishop ring can also be built where uh, that
It's
solar radiation can also be used to provide artificial
bring
sunlight to the planet also.
No, like the solar radiation will not exist when there is no
Solar
sun.
panel.
Yes.
Sir, but in Bishop Ring, the solar panels are big enough to capture light from different
Other
solar
stars.
systems.
Okay.
Yeah, yeah, yeah. Other
Okay.
stars also.
Okay. Okay. Thank you. I am done with my questions.
Okay. Thank you, sir.
I don't have any question, but I would like to give you a feedback. Priyanshu, you were laughing during the whole presentation. Was there anything to laugh in your solution?
No, sir. Actually, my friend Amit called me that his internet gone, and
Fine, but
that's
the presentation don't keep this type of attitude. Okay, fine.
okay. Thank you, sir. Sorry, sir.
Okay, we have no more questions. You can leave the meeting.
Okay. Thank you, sir.
Thank you, sir.
That was the last presentation for the day, and with that, we wind up the phase two of Polaris. We have seen many wonderful presentations on our way, and I am sure that the judging team, headed by Professor Soumya Bagchi sir, will find the right winner. Again, we are extremely thankful to Professor Soumya Bagchi sir for being with us in the judging panel. Your presence here has given us the confidence and motivation to do more such events in the future. The results of Polaris will be declared by 10th February, and I think that's all. And we can conclude the session. Again, thank you, sir, for being with us today.
Yeah. Thank you very